Okay, well, good morning or good afternoon, folks. My talk today, in the short time I have with you, is looking at how the nature of the role of developer is changing. I think our core mission isn't changing, but how we relate to the world around us and what is asked of us is changing. So, to kick things off, I want to jump right into a little bit of controversy, right? This statement, it's a hotly contested one, right? Developers need to own their own code in production, right? On one hand, you get the extreme of heck yeah, right? Give me root, get out of my way, right? And on the other side, you got the other extreme, which is, are you nuts, right? I'm here to write great code, and waking up at 3 a.m. to fix a problem in production is not going to help me do more of that, right? So of course, there's everything in between, and kind of getting right down to it, I believe that this statement is a directionally correct statement, right? Now, of course, how it's actually going to end up in the end, it's never a straight path. And also, there's need to, have, practices and tooling so we can temper these extreme positive or negative expectations that come from this this idea. So what I'm going to do in my few minutes that I have with you today is really I want to accomplish two things. One is the case for you build it, you run it, right? And the second is where to focus to get there. How we see high-performing organizations, where they're putting their dollars and their attention to a reality. So let's start with the first point, right? The case for you build it, you run it. I think it's no secret that this has been a kind of a board level focus for most companies for the better part of a decade or more, is the realization that speed is a competitive advantage. And now that software is officially eating the world, and software is at the heart of every business. Every business is really a digital business. The speed of how fast we can build, deploy, and learn is essential to the speed of the business and the ability to business to learn and win in the marketplace, right? But if you think about the traditional approach that we've taken in often building these services, you have the very traditional, we have independent development efforts, right, that have to get integrated. Maybe you have early integration environments, and then more integration environments as a pipeline progresses, which comes out the other end to a more, could be slightly decoupled or more tightly coupled, but an integrated production system. And what we see in time and time again is we have that integration friction, right, of trying to get this stuff together and work together throughout the pipeline. We've got planning friction, right? We have to figure out how all these moving pieces are going to come together in the end. And then we have the coordination friction of actually deploying and working and evolving these coupled systems. And then of course, that's just the artifact flow. There's also the information flow, right? And the friction that comes with that we've got, the dev on one side with all the knowledge of how to build the system and to tell whether it's healthy or not, and then operations on the other side, it has to catch all of that information coming over the wall and then try to pass that feedback back, right? And we see where the information flow might be slow, kind of coming over, but it's often broken even coming back because we need to get those dev teams off and working on the next the next features, and they're not participating as fully in the operations side of the work. And so you see, organizations doing now is figuring out, how can we optimize for speed, right? How can we start to decouple that instead of thinking of these more monolithic systems that we integrate early and then have to move through the pipeline, thinking about how can we decouple, how can we move to more of a microservices architecture where we're ensuring that we're having autonomy from other services in our organization. We're trying to build these high velocity plan, dev, test, and deploy pipelines. Instead of integrating early, we're looking for later integration, using APIs and application configuration in production, and ideas of moving to more immutable infrastructure, right? Immutable services, so we can keep older versions running, move to newer versions. And also the advent of this you build it, you run it team, right? Instead of having that high friction information transfer. Let's put the same people that build it and run it on the same team, and let's assign them to these individual services. Simplifies planning, simplifies building, simplifies deployment and management. And the idea being that, well, let's now build these you build it, you run it teams throughout our entire organization. I think it's good to point out that most folks go this direction. They realize quickly it doesn't mean everybody does everything, right? It's about how can we put the same resources, the same talent on the same team and have them work in a very more tightly coupled way, and ensuring that you have the same backlogs, the same priorities, the same tooling, the same context within which they're working. And also this allows us to really distribute even further and say, well, let's use the right tools for the right job on these teams. So that decoupling allows the organization to start to work faster. Things can move at its own speed. We're no longer limited to the slowest thing around us. We can work at our own speed. And as the organization decouples and moves faster, we start to see this exponential increase in velocity. And I think it's just inevitable that, as this pattern starts to grow, and you see organizations that succeed at applying it, that this really shows that they're starting to gain this competitive advantage, right? And as you see of anything, whether it was the cloud migration or digital transformations or DevOps transformations, once that idea that, hey, we can gain a competitive advantage through this new way of working, we're going to see that demand from on high. So, that's I think the speed case for why we want to move to the you build it, you run it. We need to get that organizational speed, which becomes a competitive advantage. So let's next look at, well, where do we focus, right? Where do organizations that we see high performing organizations, where are they putting their time and effort into making this you build it, you run it a reality? So there's these 4 enablers that I want to discuss. The first one here is the cloud native infrastructure. Now, I don't want to spend too much time on this. I looked at the schedule. There's no less than 7 talks already this morning that touch upon these topics in some way. Key points being container orchestration. See a lot of focus going into that. And I think, when it was originally presented, especially on the development side of the house, containers were thought of as, oh, it's going to speed up our dev test cycle, right? No longer do we have to put these heavyweight VMs. It takes 30 minutes to see the results of a build. With containers, things go much faster. I think that was, an original selling point for a lot of folks. But if you step back and look at it, it really is a key enabler to these decoupled and high velocity, organizations. And along with that, we've seen, new developments like service meshes, right? And the ability to put that integration burden into configuration and leaning on infrastructure, API-driven infrastructure to do that. Obviously, serverless, big rise in that, and much more. But again, a lot of talks on that, a lot of places to go find information on that. And then there is the next one here, monitoring, observability, and AI ops. And there is only 4 talks this morning on these topics, so I can spend a little bit more time on that. And if you really kind of break it down, monitoring, has long been really the domain of, the operations side of the house. And it's really about the known unknowns, right? So how should we be thinking about our monitoring? It's the looking for patterns, looking for things that have happened in the past or things similar to that. And, being alerted when something is actually going to, one of those things are triggered. But then I think we'll see, they're seeing the new emphasis now, which is on observability, right? Which is not really a monitoring versus observability. It's really a new layer of visibility into our world. And this is really about answering the unknown unknowns, right? Being able to, really interrogate our services and find out, what's going wrong here, right? And it's built on, these kind of key concepts, right? Events, this discrete event that something has happened. Metrics, looking at those events and saying, are things getting, better, worse, up, down, left, right, whatever that metric is that you're measuring and seeing over time. And then this really critical capability of distributed tracing, right? Being able to look across these new distributed infrastructure and understand how those events, cross through each each component. And what's very interesting that we've seen is that, while monitoring has traditionally come from the operations side of the house, we're seeing observability really be driven by the dev side of the house. And I think that the merging of the two really brings a very powerful level of visibility. And it also, I think, coincides with that merge towards those you build it, you run it teams, both bringing these two different directions of visibility into operations. And then there's AI ops, right? Which is, something that I think there's, many definitions out there for. But if you think about the key role here, right? What it is all this information, all this visibility, all this signal that we're getting from all this infrastructure. How do we aggregate it? How do we reduce that noise, right? How do we improve the correlation of understanding, what's related to what, and how do we spot these patterns, right? And I think a key thing to realize why these technologies are so important is that our systems are only getting more and more complex, right? And this is, I think, a very key concept because when you come from, I think, the development side of the house, things seem more deterministic, right? That I write code, I build the code, it works or it doesn't, right? And when you get into operations, you find that things are much more stochastic or variable, right? That you see this true complex behavior where you not only have, the software that you wrote, the very possible variability in the hardware. You're now depending on third-party hardware. What's going on there? Network traffic, right? That's very highly unpredictable. User behavior, it's very unpredictable. And so on and so forth. So the idea is you have, and then all the different human beings interacting on these systems. So you truly move from being a deterministic, hey, I wrote it, it compiles, it works or it doesn't, to a much more complex world where you might be doing the same thing over and over again, and you get a different result each time. And I think these visualizations here I'm showing on the screen come from a project, a university project called the Death Star visualization, right? And what they've done is they've built these tools that map out these real-time microservices architectures. And what's going on here is around the outside, there's these those little gray text you can barely see. Those are all the different service instances that are running in the production environment. This is actually a kind of a mid-size social-oriented app. And all the blue in the middle is all the different communication paths that are happening between those services being tracked in real time. So obviously, things have exploded beyond the point where it's something we can keep in our heads. And you imagine all the variability and things that are introduced and all those endpoints. The complexity just gets off the scale. Now, of course, you put those on, the global scale infrastructure like Amazon or Netflix, you can see it just explodes exponentially. So, the critical part of all this is we don't have this tool. We don't have the observability, the AI ops, all the latest monitoring techniques. It becomes almost impossible for us to, to spot and diagnose these problems in real time at the speed that we need. And so we can expect this complexity to only get worse, which means, the human brain, which is great at spotting problems, needs to rely on these tools to sort through the noise. And it, brings me to the next topic here, which is the idea of service ownership, right? And, back in the days when we had less moving parts, right, less services to worry about, smaller, less connected organizations, the idea of, who owns what, right? If something goes wrong, who do I call? If a question, who do I reach out to? Who owns the documentation? Who owns the API definitions? Who owns the runbooks that need to be maintained for each of these pieces? And in this new, increasingly complex world, this notion of service ownership only becomes more and more important, right? And we have to start to rely on tooling to help us understand this. And what are the dependencies? Who is the person responsible for these things? Who do we turn to for answers? In fact, there's some organizations like Netflix and their famous chaos monkeys, right? That are famous for randomly destroying things in production environment to test the resiliency of their services. They talk about how they have one of their monkeys which is really aimed towards compliance, which really is about service ownership, right? It looks and sees, hey, for every service we have running in production, is there someone's name associated with it? And if that name is missing, or it checks the corporate directory and that person no longer works there, that service ownership is broken, and it will automatically deprovision that service, no matter what it is, right? And the strong message that it's sending there is that we can't live in this high velocity world where not only is our organization moving quickly, but our customers have these super high expectations around availability. Without strong service ownership, all that falls apart, right? And this also becomes very valuable for when it's not just incidents, but just in day-to-day activity, right? Understanding kind of who's related to what's related to what, and knowing who to talk to, or who to turn to for information. So service ownership, we see becoming increasingly important, and something that people are focusing on in terms of their tooling and their practices, when in the past it really just kind of happened more organically. So kind of the simplest way I like to think about it is the service ownership really builds that map, right? It helps us understand the interaction of the socio and technical systems that we're dealing with. And fourth piece here, right, which is something that I do want to spend a little more time talking about, because I think we have the most, I have the most standing here, and that's really the idea of real-time operations, right? So we have this new idea that, hey, we're going to decouple our organization, and that's going to bring us speed, right? And we have the tooling and the infrastructure to help us build these decoupled microservice-oriented systems. But what about the people, right? If we're going to just to put these people together and say, hey, we now have these integrated teams, we're now going to both build and run these systems from these teams. We're pulling the dev and the ops activity together. But how do we stay out of their way, right? But stay under control, right? And this is a very key point, because you have to avoid the friction and the problems that occur in operations today, right? And I think that's something that you always find when developers get involved in operations, is they're kind of shocked at how things work differently, right? In development, we have the blessing of being able to lock things out, right? The whole basis of something like Scrum is about locking out our time and saying, we're going to focus on this and we're going to get this done, right? But if you look at operations work, it's really one of the few places in business where planned work and unplanned work are equally weighted and happen simultaneously. So, the friction of that, how do we stop that from pulling down these teams? And as we combine them together, we don't want them to slow down. We want them to actually speed up. So first, I think when I look at what we want to avoid, and that's really, the status quo of operations work today. And I'm not, saying this is all organizations, but I think almost everybody takes a look in the operations world will find this to be pretty true. First thing about operations, once you step into the operations arena, is this idea that you're going to get interrupted a lot, right? Whether it's tickets, whether it's direct messages, whether it's the cube drive-by. There's constant interruptions. I need this to happen, or why is this slow? Or hey, if this, if we change this, what's it gonna do to that? So there's constant feeling of being interrupted, right? Including with incidents as well, right? And then at the same time, when it comes time to actually go and get something done, okay, I've gotten rid of those interruptions, I'm going to go do something. Now you find yourself having to wait for somebody else, right? You need a new environment. You need something, a firewall rule change. You need a report of what's running in production. There's some maintenance activity that you have to do, right? Some database update, right? You're now opening a ticket and waiting for somebody else to do something. So you go from being interrupted a lot to being the one that's doing the interrupting. And then you get this pressure from that you see a lot from the executives, which is, hey, it feels like everyone's busy. We're working 110%, but the things we want to see happen, the things that move the business forward, just aren't getting done, right? All this friction and overhead of interruptions and waiting slows down the project work that should be moving things forward. And so, the way we've been talking about this is as ticket time operations, right? That we're moving at this kind of slow pace because things are being routed through ticket queues across each part of the organization, and you're either constantly getting things pushed your way, or you got to push it on somebody else. And how we really got into this is in natural sort of growth, that when organizations scale, they tend to organize by specialization, right? Put the like with like, the DBAs, the DBAs, the network team, system teams, the system team, so on and so forth. But nothing lives in isolation, right? You always need something from some other team. But those teams have, been prioritized and have been optimizing for their own thing. So their priorities, their processes, their tooling, their capacity, everything gets a bit mismatched, and this causes this misalignment. And so when work has to flow across these different, specialist teams, you get a lot of conflict. And so what we did is well, let's fix that misalignment by putting this thing called the ticket queue in there, right? So if you need something, you fill out a ticket, it goes in the queue. Somebody has their own priority of what to pull off the queue. Maybe you got to get a project manager to go, push something through the queue. They read it, they look at it, they come back to you, try to get more information. Got to do a couple times because it gets wrong. So we get this kind of slow and disjointed way of working. And, that helped us with these mismatches, but we didn't realize that we should have looked at what happened in the rest of the industries, things like manufacturing and other endeavors. Have realized that working through queues is very costly. There's a lot of research around this about how it causes more delays, more variability, more risk, more overhead, lower quality, less motivation because things take so long to get done. And we ignored kind of how that happened to the point where, as the complexity, the scale, and the speed has grown, this way of working hasn't been able to catch up. We've created, our engineers, they're frustrated, they're overworked, they're underutilized for their core capabilities. It's all this busy work that has to happen on top of it. And they're burdening our businesses. Things take too long, cost too much, break too often. And now this threatens these new operations models, right? Again, nothing lives in isolation. So we can't put everything into these you build it, you run it teams, or these teams do need to coordinate, and really threatening to undermine these new operating models if we have this same kind of ticket-driven way of working. So we see organizations focusing on this move from this ticket-driven way of working. The ticket queue really is the problem, not the ticket itself. From that slow, high friction, and costly to more of a real-time focus, right? Where you want instant communication, things be frictionless, and focus on that efficiency. And how really that happens is about enabling this real-time decision-making and action, right? Instead of having the information and the control be focused in these different silos, how do you distribute that out to the organization? Part of that is through intelligence and communication, the context, all of the visibility things I was talking about earlier, service ownership, the ability for real-time collaboration, know who to contact and for what, and also the right run books and decision support to drive through that, combined with self-service, right? It doesn't do any good if we keep having to go to other people to do things. Turn as much as we can into self-service using runbook automation and or event-driven automation based on what's going on in our world. Oops, sorry. Slide there. And runbook automation being the key piece there, in that it's really about how do you take the subject matter experts, right, and let them define the workflow that spans all the different tools and scripts and APIs and manual calls, and give that control to anybody who needs it, right? So it's enabling anyone to do anything that previously only your subject matter experts could do, but do it anywhere where it's needed. And it's really across the full life cycle, right? Whether it's an incident response, in the past you get an alert, and you have to go and figure out yourself what to do, probably escalate quite a bit, or looking through wikis or shared scripts, to where now you have the ability, you're pushing to those responders, whoever it might be, and whatever team it's now going to happen in, to understand what's going on with the alerts and have the automated actions at their fingertips that normally that they would have to escalate to the experts could do, which works just the same in our during service requests, peacetime, the stuff that needs this, the maintenance requests, the provisioning requests. How do we avoid that constant waiting for someone who's overworked to do something for them? Use that self-service automation, that runbook automation, to enable folks through self-service. And like I said, this is because this real-time operations that it applies beyond just incidents, but really to all the operations work that has to take place. So whether you're in a traditional operations organization or in these new you build it, you run it teams, how do you enable for all this operations work, the distributed communication and information and context that you need to get your work done, as well as that distributed control to get things done. And kind of as a closing piece here, keep compliance and security happy, right? It's one of the biggest things we see, and especially in enterprises, when you say we're going to move this you build it, you run it model for speed, is compliance just goes, whoa, what's going to happen here, right? We're now going to distribute the ability to deploy things, to work in production across these different teams. We just can't possibly have that happen. But by using this, by using Rundeck automation to do that, what you're able to do is you're able to define these procedures and say, no, we're not giving direct access to these environments. We're actually giving named access through these. Sorry about seeing my text there. Through these the Rundeck automation facility that enables us to satisfy compliance and satisfy security, because they realize, oh, we're working on these procedures that have been vetted. Security can look at them, compliance can look at them and say this is good, and we're able to distribute that control throughout the entire organization. So recap: speed's a competitive advantage. You got to rethink how work is getting done, right? The you build it, you run it model, I believe, is inevitable in some form. I'm sure whatever comes out 5 years from now will be slightly different than what we imagine, but this direction everyone's going. Complexity is rapidly increasing and unavoidable. I think these 4 focus areas are key areas of investment and worth the effort. We got to avoid the status quo of operations. Otherwise, we're going to pull these new teams back into the same kind of more broken and slow way of working, which means that when we move from that ticket time to real time. And the bonus, most people don't think this is possible, you can really make security and compliance your friend. So that is my talk. And if you want to talk about real-time operations or service ownership or AI ops, you can click on over to the PagerDuty virtual booth, just over there in the expo hall. And if you want to contact me, there's my information, Damon@PagerDuty.com or at Damon Edwards on Twitter, if that's your thing. So thank you for your time. Hopefully I open your mind to some new ideas, and love to hear from you.